Yeah, just keep on going and don't question why the technology is struggling. Just hope it works. It usually does work. We got the last video up and recording, and this is the first one streaming to YouTube. Let's close all that.
All right, let me know if I'm
I
missing
was
it.
mentioning that since there's a lot of windows changing at the very start of class. Oh, sorry, did I miss a question there in Zoom? Okay, probably an open mic, but welcome back, folks. Looks like we're about ready to start. And usually class is going to be kind of chaotic starting off because of that recording, but usually this is what I do is I'll share, unshare, that kind of stuff. All of my annotates I put on here disappear. So we go to the screen where we just pull it right back. And here's our announcements for the day. Usually I'll try to put something on the Moodle website. If you come in class in person or in Zoom, it'll usually be parked right here with the screen share. So you'll know about what we're doing on that given day. So we're on chapter 1. We're going to continue on working through example 3, possibly finishing off the notes in this class today. Then we also have our very first assignment number 1 that's due. And if I scroll down a little bit, the last announcement is we won't meet on Monday of next week. We'll be on the next upcoming holiday. So we're going to meet again in 1 week away from today. Well, any questions at all, folks, with either of those announcements or other questions or comments? Okay, well, let's see here. After the announcements, let's just close this. Other things I want to point out, since usually during week 1, there's a little bit of changes in the rosters. Some people drop out, some people add the class. So for folks who just add the class, just a really quick reminder of what's here on the Moodle website. I'll be using this for the first time ever this semester. Someone notified me that this is actually pretty useful. It sends out a message to everyone. It bounces to your ISU email, and it also leaves a message here so that there's a paper trail of different announcements we might make. So I'll utilize this pretty often whenever I'm trying to message the entire class. The syllabus is also here, but I did make a revision just today. My revisions, if I have to make them, I try to put them in red so you can track any changes. And really the only change was I added a Tuesday to the office hours right here. And I wanted to say, just to be specific, that these office hours in room CHE 220, I'll also try to be available in Zoom as well, so that you won't feel like if you're not on this campus, you don't have the same amount of office hours. That doesn't sound quite right. Now, this room is kind of special. This is the Math Center, and it is not open this week. So that's a little bit awkward for our syllabus. What I'll be doing on this Thursday, I'm just going to be in tab 268 and also in Zoom as well. Then starting next week when 220 opens up, that's when I'll go from 3 to 5 into that location. So that's the changes on the syllabus. Any questions, folks, about that at the moment? Okay, then going back here. Other things to mention are the Zoom link is available. And this is really for anybody, especially if there is really, really terrible inclement weather like we had yesterday and today, probably tomorrow. If it doesn't look safe to drive to work or come to school, drive to work, that's a weird thing to say. If it doesn't look safe to come to school, you're always welcome to use this Zoom link, even if you're registered for the in-person section. Also, all of our classes, I'm going to attempt to record them. There could be some glitches that are beyond my control, but we've got our first recording. It's right here. I'll try to also put details here so you know just what happens on each one of these videos. So they'll all end up right here under recorded lectures, and let me fix something real quick. There we go. After that, we discussed RStudio, how to install it. The link is right here. And all the reading right here is purely optional. This is also optional, the homework help server, and I think I accidentally closed that. I thought I had it open. Let's take another look at it. I don't think I was able to even open it last class. I was struggling with the password. That's a weird way to open it. Let me just left click on it. So I myself am very new to Discord. I can tell that's not the best way to get inside there. If you want to join the Discord server, this is the invite link. I think is how all that works. Let me try to open it more directly. Hopefully it works. Yeah, it looks promising. So this is our Discord server. MASH, Mathematics and Statistics Homework. And the way to use it is, well, you could go to any one of these channels, but if you're working specifically in this class, statistical methods, you're probably going to go here for homework help. And there's been no homework help just yet, but we only just put in our first assignment. Here's the things you could do here. You could just ask a direct question. Hey, anyone working on problem 3, see what this turns out to. And this will all be really just students interacting with fellow students in this class, helping each other out. And you could literally do things like this as well in the Discord server. We have our assignment 1 posted. Let's take a look at that. And let's say you're working on maybe this one right here. You could just take a screenshot if you like, use a snipping tool on Windows or one on Mac. There's a really fast way to do it on Windows. You can use the Windows key, hold the Shift key, hold the S key all at once. Pulls up this little weird screen, and now your mouse is free to just select exactly what you want to throw in there. Go back to Discord, and that should paste in. So now you have a problem there. You can write anything along the text, anything along here, along text-wise, and say something along the lines of, hey, anyone see what kind of data this would be? So that would be how you might interact with the Discord server. Again, I'm pretty bad at it, so the way I'm thinking of this is just an ordinary kind of message board type of thing we've got going on here. If you want to do a little bit more coordination with fellow students, you can also go to the voice chat right here, where you can do things like screen sharing and do some really decent and pretty okay study groups, I'd say, especially if you want to do that between students on different campuses. So this is all completely student driven. I'll try to check these out every now and then to come in, help out, things like that. But it's all for you. It's completely optional. If you hate Discord, then I'd say don't even worry about it. I probably won't talk about it too much throughout the semester because of its optional nature. Let's go back to the Moodle website and, oh, I really got lost. There we go. And so that's the purpose of the Discord server there. And last thing to mention again, we're going to go and upload all the solutions that we produce on every one of these chapters. So if you open up, say, the PDF or the Word document, this is what we did last class. Sometimes I do make some small changes. I actually do try to proofread these so that a mistake or something like that just doesn't get lost up there forever. So you might see some changes, or maybe it got too scribbly here and I have to try to clean it up. But most often than not, it's going to be the actual things that we did in class ourselves. Gets posted right back there. And if you want the blank document, just go to blank lecture notes up here. Well, that's the really fast orientation of the Moodle website once again, folks. Any questions or comments at the moment? Okay, then we didn't take our full class on Monday. Usually I do Tuesday, Thursdays classes. This one's Monday and Wednesday. But we mentioned the last thing you'd probably want to do to be considered caught up in a good spot is install RStudio. So if you click on that link, it's a pretty quick installation, but there's 2 programs. You need the base program R itself, and you could get away with just using R, but it's tough. It's very, very bare bones. There's not a lot to help you out there. RStudio is what you'd really want to use. It makes everything you do in R a lot easier. Lots of quality of life improvement type things. I believe this is called an IDE for Integrated Development Environment. I'm not a programmer, so I don't know what that means, but it means it's a helpful little program there. So install R first, install RStudio. Then your desktop might look something about like this. I put here, do not use this icon. If you use this icon, it's a tough way to actually interact with the program. Let's use it to just show what it looks like so we know what you probably don't want to do. This is ordinary R with nothing on top of it. And everything you do is through this command line right here. You have to know all the commands, things like that. It's not terrible, but probably the worst thing about this is importing data right into the program just from a drive on your computer with this package is tough. So that's already just kind of a nightmare, just data import. You have to be pretty fluent with that. Let's close that. What you really want to use is RStudio, this program down here. So after install, you can just delete this icon from your desktop. Let me see if I can. Oh, no, I need administrator access to do that. So I can't delete it. I'll just hide it. Put it over there. Be sure you're using this one right here. So if you open up this RStudio, it's kind of overwhelming at first. Update this apparently. I'll do it later. Let's say remind later. A lot of the stuff that we're going to do is really just going to be typed right here. So this is going to be our script. Occasionally, we might do some computations here using it as an ordinary calculator, for an example. Any variables that we define or any data frames that we upload are going to end up here. Whatever graphics we decide to produce or other things like maybe we're looking at packages or help, it all would go right over here. So primarily you're typing up stuff here, getting output down below. It's how you're going to be using RStudio. Let me move some of these just a little over to get screen space going. One of the things that's kind of difficult about this class is the resolution on this monitor is not great. There we go. But it's better than what it was. They did upgrade the projector in this room, so we're better off than where we were. So we'll come back to this program, but any questions or comments so far, folks? Okay, let me actually change that to this. I think I have enough space for something like that. There we go. I want to have 5 chats. Sorry, folks, I forgot that I also enabled chat. And Savannah said, fancy place to program easier. I think I missed the time that was in. Sorry about that, Savannah. Olivia mentioned, has anyone with a Mac had issues downloading R? Savannah said, I'm not on Mac. Yeah, it won't let me download it. That's really strange. Sorry about that, Olivia. It should be very well supported for the MacBook, but let me see if I can get any extra support on that. I'm going to make just a quick post-it, and I'll get back to you. So install RStudio with Mac. Okay, sorry you're having trouble with that, Olivia. The good news is we're not going to use it too much so far. And so you won't be in too bad shape, taking a couple extra days getting it working. I'll see what I can do to help out with that, and I'll get back to you. Other questions so far, folks, at the moment? Okay. Now, one thing I should mention is it's really easy for me to miss a chat for one reason or another. I don't know. I think I have just tunnel vision when I'm doing this kind of stuff. So if you notice I had a chat and you notice I also missed it, don't hesitate to just yell out, hey, Mike, you've got a chat. That's never considered rude. Whether you're in person or Zoom, just yell it out and I'll be better directed. Sometimes this kind of stuff is a bit of a group effort. Okay, so that's our RStudio, but let's now go back to where we left off on the chapter 1 work. So, well, really that's kind of the end of my announcements. Before we jump back into chapter 1, any questions or comments so far, folks? Okay, well, we're through the announcements. We're in chapter 1. Everything that's in all of these folders, I have completely duplicated on the thumb drive. So you usually see me just point at chapter 1. We're going to these notes right here, but I would just pull it from right here. So this is where we left off last class. And just a kind of a reminder just to get warmed up. We were looking at this large data set. And in this data set here, we had to indicate which variables were going to be considered quantitative and which ones were categorical. We said all of these variables were quantitative because these are the variables for which it makes sense to do ordinary arithmetic operations like addition, subtraction, averaging, standard deviations. On these variables, their whole purpose was to classify each one of the children amongst the different categories versus sex and smoke. And so those were the categorical variables. Now that we know what the variables are and we have the data frame, what we want to do next is look at some graphics just to get a feel for what does the data really look like so far. But getting graphics can be tedious. Sometimes it takes a little bit of practice, and that's where RStudio comes in to help us out. We would like to, for example, know the distribution of this variable and many other things we'll try to get graphics on. And that's what we're meaning here when we say the distribution. It'll tell us what values each one of the persons take, how many times often it's taking. If we want a distribution of, say, categorical variables, really all we're going to go for is a bar plot or a bar chart. So let's go for that next. And we'll do that on our example 3 here. First, any questions, folks, with what we did on the prior example or going forward? Okay, so this is a real data here on example 3, but it's kind of been simplified. It didn't give us a ton of context to work with. It said criminologists have long debated whether there is a relationship between weather conditions and the incidence of violent crime. I guess the thought is if it's really, really hot, like 110 degrees, AC is not working, people are just upset and more likely to get on each other's case. Who knows? Then it goes on to say the article, "Is there a season for homicide?" from 1988, classified 1,361 homicides. I believe this was from a specific region, but again, that context is missing. According to season, resulting in the accompanying data. So 1,361 homicides was classified, and this is our data right here. Truly, this is the distribution of the variable. The variable is going to be considered categorical, and it's telling us what the categories would be, these 4, and how many times are being taken. Those are the counts there. But you know what? This is actually kind of a tricky problem. It says for each variable in the study, it's kind of a trick question. There's really only one variable. Indicate if it's categorical or quantitative, and if it's categorical, we'll describe its categories. So same verbiage as we saw in the last problem. But here's the challenge here. You look at the very last problem, this data is very, very different than what we're looking at in the current problem. Here we were listing out every single individual and all the measurements made on him or her. Here, everything has been aggregated. That's not what the original data would have even looked like. So let's take a look ourselves. The original data on example 3 is, well, there it is, example 3. Kind of hard to see, let me zoom in. This is what the original data might have looked like. If they took a random sample of 1,361 homicides, there's no expectation that they all were sorted according to the season. It might look like this. Here's the first homicide they pulled, and it happened in fall. If we go to, say, way down here, maybe the 180th homicide happened to be in summer, and just by chance looks like 4 in a row, and so on. So this is what the original data looks like. This right here, where it says homicide, that's not the variable. This is sometimes thought of as kind of a, oh, I forgot my words on that. It's not a variable, it's just telling us which individual we're looking at right here. The variable itself is actually season. So these things are kind of hard to track sometimes, depending on the form you actually see the data. And with categorical data, it's very typical to take all of this stuff and just count the number of seasons that correspond to winter, spring, summer, and fall, and just present your data in this way. But that's tricky. Season, that's not the variable. Counts is not a variable at all. That's just the data being aggregated. Here, oh, let me grab the right pen. Here we just had the one variable, which was homicide. This variable is categorical. And we can say the categories or the outcomes for that variable, well, they're just the 4 different seasons we see here. So we'll say here, the categories, you could just write them out, winter, spring, summer, fall, or we could say the 4 seasons indicated. Anything that says exactly what we're seeing here is always going to be considered full credit. But I'll just write them out. Sometimes that's the clearest thing to do. The categories are winter, spring, summer, and fall. So this data right here is definitely kind of a tricky one to get the variable in because of the way the table was given to us. Does that make sense to folks on getting through this one here? Okay, But I feel like this is tricky enough. We should look at this in the homework. Homework assignment 1 is meant to be, we're all still trying to get on the same page. And so that's definitely appropriate. And a homework assignment 1, there's another problem that's pretty tricky in that way. So I just went to assignment 1. If you click on that, it opens a folder with everything you might need here. If there's necessary data sets, it'll also be included as well. And in assignment 1, this is very tricky as well. We have a data set like we're used to seeing, and it tells us for each variable in the study, indicate if it's categorical or quantitative. And I threw in as a hint, that's the word I was looking for. It's not a variable at all. This is just an identifier. This is much like when we were looking at these data right here. The lake name is just saying which individual in the data set we're considering, much like the homicide number. These are the identifiers. They're not variables whatsoever. So when you go to specify the variables in this problem, you're really talking about pH through age of data when you go to give the classification. In other words, there's only 5 variables in this particular problem. Does that make sense to folks on those kind of weird issues sometimes? Okay, so this particular data set, there is an identifier saying which lake are you talking about. Same on this one, which homicide are you talking about? But once you go to this, the identifier variable is gone. And this data set never had one. If it did, it might have been just the subject's name or something like that. Maybe a student ID. They were children in a school system, something along those lines. So this one never had an identifier, and neither did this one. But I think that's why we put in the homework a hint. This one did have an identifier, something new in this problem. Well, we've got our data set. We see the counts. And now if we were trying to answer the question, is there a season for homicide? We might say, well, we might debate on that quite a lot, right? These numbers look to be about the same. There's definitely a bump on summer right here. We could convert these to percentages to get a better feel, but sometimes the best thing to do is, let's just give a graphical display for these data. That's what we'll do very next. So I'm getting that graphical display. We're going to use RStudio to make it happen. And you can pretend right here on example 3, you're doing a problem much like that on exercise 4 here. So these problems are going to go together very, very similarly. This one's also asking us to construct a bar plot. So we'll paste that in here if it's a homework assignment. But for the lecture, we'll just paste it in here once we get that plot going. First, let me see if we can get our windows to work a little bit better. It's not too bad. So what I need to get this going is, well, first, we want to get rid of all the stuff here. Just hit Control A, delete, and it's all set up. Now, if you don't see this at all, if your RStudio session looks like this, probably the first thing you want to do is just open a new script. There's a shortcut for that. I think it's Control-Shift-N, but you can also go right up the far upper left corner, click on the plus, yes, Control-Shift-N, or just click on this, and it pops out your R script. A lot of stuff is done right here as a best practice. If we make a mistake, it's much easier to edit than working down here in the console. So first thing we want to do is, well, we got to include all this data. Let me start with counts. We can write in RStudio, type in any variable name, preferably something that makes the most sense. Counts does a great job, so let's just stick to counts. Here's where things get a little bit weird with R and RStudio. You can do a variable assignment with equality, but for reasons that I'm not quite sure, best practice for the R language is use the left arrow. So hit Shift, comma, right next to your M, get a little space here, and the left arrow is just read as gets. So counts, gets, you have to give it all that information. But we want to think of that information as a list of numbers or a vector, so we have to combine them some way. The good news is, up here, just hit lowercase c, and that's how we combine data together to create a vector. So after you put in C, that's one of the bigger operators inside of R. Open a parenthesis. Notice it also closes it for us, just as a quality of life measure there. type in all that data and just comma separate it. So 328, comma 334, comma 372, and 327. I put in these extra spaces just so if I made a mistake, it's easier for me to see. If you typed it out like this, that's completely fine. RStudio is just going to ignore the white space. So sometimes formatting is a good idea. If I put in like a period instead of a comma, that might be invisible unless I try to format it so I can see where I might mess up. Another thing that's not a bad idea is, especially when you're learning to use RStudio, after you type in a line, you might hit Control A to highlight everything, then hold Control Enter to run everything all at once. If you get an error, you'll know right at this line, the error must have been the last thing you put in. So I'll often do Control A to highlight everything here, Control Enter to run it. And it did run, you see it down here in the console. Less exciting, more importantly, is we see it also up here in the variable assignment. We can open that just a little bit more. It says the values is, we have counts, it's numeric. One column 4 says we have a row vector, or let's think of that as a column vector with 4 different entries, and these are the different entries. So halfway there, folks, now we need to import season. Any questions so far, however? Okay, this one's not so bad. I'll go season, left arrow for gets. We have to combine the data once again, and then an open parenthesis. The trouble with these data is it's considered to be a string, so we can't type it in directly. RStudio won't know what to do with it. What we'll do instead is hit a quote, then just type in winter. Go to the right of the quotations and rinse and repeat. So anything that comes in with ordinary words like this, which is going to be almost essentially guaranteed for categorical data, we'll just have to type out the categories using quotes. So let me get the rest in. Spring, summer, fall. Then just to make sure there's no weird issues there, I'll hit Control A, Control Enter. And we've got it, folks. There's the next variable assignment here. Now we want a bar plot, and it's easy to forget what the commands are in RStudio. I don't have a great working memory for this. I often do forget. It's either bar plot or it's bar chart. But the good news with RStudio is if you're not sure, just type it out slowly. It's got to be bar plot. That's the first thing that pops up. That's got to be the function we want. It tells us a lot about the function just from this already, but you can use your cursor at this stage, up arrow, down arrow to select the right function you really wanted. Sometimes that is a huge quality of life step right there, especially for data import. Let's go bar plot. First thing we'll give it are the counts. Let's just close a parenthesis right there and just see what happens. This is not the plot we want, but we're building up towards it. Let me make this a little bit bigger now. We run everything at this stage, Control A, Control Enter, and we've got it, folks. That's our bar plot. Looks nice. I mean, it's about what we expect to see, right? We have 4 different categories, so that's okay. One of the categories has a slightly higher count. There it is. There's a little bump there. But let's suppose this was really important research, not a simple problem with simple context, and we were about to publish it. There is no way you would let that go, right? You would want to add more to this plot for sure. It needs labels for all of its axes. Anyone see what the label should be for the vertical axis going this way? Is that counts or is that season? Good call, that should be season, absolutely. So we want to take these seasons that we imported right here and drop it down as a label. The way to do that is go back inside the bar plot. Our first input was counts. Now we want to put a label down this way. This is really kind of weird the way it does work on RStudio. For a bar plot, we use this argument, names.arg, so that first input you see there. Now this is another thing that's interesting about RStudio. Best practices say for variable assignment, use left arrows, but if you're working inside a function like bar plot, and you're changing some of the arguments of the function, we use equality right inside. We don't use the left arrows in this case. We'll say names.r gets, or excuse me, is equal to, up here, give it season. That should do the job for us. Let's take a look. Looks like it broke, but this is really just a graphic issue when you're dealing with RStudio. If your plot looks broken, here's what you can do. Either move this portion in the screen here until everything suddenly fits, or just maximize things out and make it work. You'll notice that your plot is going to have a different look depending on how you size your window. That's kind of weird in a sense. Oops, let me fix that. There we go. But another thing you can do here is you can go to the export key, click on copy to clipboard, and in that case, you have a lot more control in making your plot look the way you would like it to look. I'm not really picky at all, so the things you'd want to avoid are something like this, where the plot just becomes unreadable. RStudio apparently doesn't even want to deal with it. Make sure you have at least enough vertical distance here, enough horizontal distance to see the categories. And if you did put this as your response on the homework, I'd say that's okay. That's full credit for me. That'd be a decent plot. I think the reason it's okay is it's understood that in a bar plot, this is probably the counts, right? It's got to be. We've got the season going this way. But if we want to be a little bit more specific, we can add a Y label right here. So let's add one more to our plot. One thing you can do here on RStudio that sometimes helps out is you can type all of this on a single line, but sometimes that gets out of control and you're going to have to use this scroll bar to see if there's mistakes anywhere. What I would do is just try to fit everything into a certain window. So for example, instead of trying to type in the next input here, just hit enter. Everything drops down and just keep on typing on the next line. RStudio is going to ignore all of that white space, so there's no issues there adding an extra line. So what we need next is counts going this way, and this will be Y. We want a label, so put in lab for label. And RStudio is indicating, yes, that's a function that exists. You can work it that way. Y label will get. We want to say counts. That's never going to work, right? We're giving it an ordinary string. So instead of saying it counts that way, put in the quotation symbols, and then you're in good shape. Let's double check that, see if it really works. Hit Control A, Control Enter to execute everything. And looks like I've completely ruined my graphics. There's some problem somewhere. And dot try catch return expression name handle, something is wrong there. But we know the last thing I did was this YLab label gets counts. I'm kind of stumped on that. Anyone see what could be wrong there? You know what? It printed it. It's odd. Let me see if I can run it again and see the issue. It worked without error this time. You know, I really should probably update RStudio. I think that would help us out quite a bit. I'll make sure that that happens before we come to class next week on Wednesday. I'm really going through these post-its. Update RStudio. Well, we've got it, folks. We have some graphics. There's lots of ways to import this to your assignment. One way to do it is, again, you can just click on the export key, copy to clipboard, resize it any way you'd like. Really kind of up to you. And then click on copy plots right here. That's a way to do it. So if you don't like that process, there's a lot of ways to make this happen. Now that the plot's copied, you can go down to your assignment, paste it in, Control V or right click. It should have pasted. Let me try again. Oh, no, it did not want to go in there. Some weird issues with RStudio today. The other thing that also definitely works is just take a screenshot right at this stage. Hit Windows, Shift S, select this area, If you drop it in like that, now we've got our plot. Does that make sense to folks on getting that plot into the document? Okay, it's best to put the plot right into the problem right here, but if you have a different process, maybe you're writing out your homework by pen, and you just want to print out these plots and attach them to the very end of the assignment, that's okay as well. You could go to your assignment and just say, see the very end for the plot, something like that. I'm okay with that. I'd say it flows better if you put it right in to your Word document, right where the problem is. But one thing you are also allowed to do is, it doesn't have to be this big. You can resize these. I have a pretty powerful script for my glasses, so you can make it pretty small. If you can read it, I'm probably going to be okay as well. We did it, folks. That's our first set of graphics. I want to add a couple things here just on the notes for what we're looking for. We should say here, be sure to include labels on this axis. And there's a lot of things we could do additionally. We might have decided, for example, that our studio itself chose this range from 0 to 350. If that irks you, we can make it go to 372 or 400, anything like that. There's a lot of little things you can change here. And this is just the base graphics package. If you are really interested in graphics, there are a great deal of additional add-ons. But for this class, I'm not going to try to go crazy fancy on the graphics. If you can produce this plot, you're in great shape. And it seems concerning because this was our first use of RStudio, and this is what we had to do to make that work. But anytime we do put in a script in RStudio, what I'll always try to do is copy this, go to the document for the lecture notes, paste it in. I did not get a copy. Let me try again. Go back here, copy this. I get in the habit of pasting them in, and I'll always try to box them out. That way you'll know that this is just a syntax region for RStudio. One word of advice though, you can copy this in to RStudio and it'll run correctly, but I heavily encourage everyone, never write your script in a Word document itself. That can cause all sorts of amazing issues. One of the issues is just the quotes. That quote right there that you see, if you import it into RStudio, it's different than these quotes, and that's enough to break the whole system. There's probably loads of other small issues like that. So best places to type your script would be in RStudio itself, or you can get Notepad. Notepad's really great as well. Notepad++ adds even more features and things like that. So that'd be a good place to type them out. Other things I want to mention is also with, let me get rid of that. When it comes to this kind of syntax, this is really for help with homework a lot of times, so that if you're asked to produce a bar plot, you can come down here, reverse engineer how it worked out. But another thing worth mentioning is our class was not meant to be a programming class. If you're doing a homework assignment, and let's just say I had a weird issue here that I could never find it. If you're doing a homework assignment and you get these kinds of messages, reach out right away. I'll always be very happy to help. When it comes to this, it's really, there's no secrets. I'll always be able to tell you exactly what you need to change in your script. If you take a screenshot of this and email it to me, I'll stare at it really hard, and I might be able to find out that right there, it should be a comma, not a period. So email me your scripts. I'll try to figure them out and help you out. And if we can't get it worked out through email, we'll do it over office hours potentially. But for the sake of completing assignment, we're struggling to get that plot for the homework assignment. I'll just send it to you through email, and you can use it and work it in your assignment. Make the, let's see here, make the part C work out for you, because we're not trying to make RStudio be like this overly awful kind of thing for this class. It's a little bit tough getting started with it, but I try to give as much support as possible. And if we can't get that bar plot to work out despite trying, that's okay. We'll work through it, and I'll send you an email, the plot of what it should look like if we couldn't make it happen. Any questions about that so far, folks? Okay, and let me double check I haven't missed a chat at all. Okay, we're good so far. Any questions for folks specifically in Zoom? Okay, well, we did it, folks. That's our bar plot. This is season where the homicide occurred, and these are the counts for the number of times it happened. Last thing we'll do for this is just describe what we see in the box, or excuse me, bar plot using the context. Let's highlight this right here and talk about it. When it says using the context, we have to say something about what's really going on. We can't say, for example, the highest category is summer. This is about homicide, so we should bring that context in as well. There's a lot of different things you can say here as well. And as long as it's whatever you type out here makes sense based off the graphics and the context of the problem, then that'd be completely fine. We'll leave it up to the class. Any volunteers for a line or two to say here? Absolutely. That would be definitely what you want to mention right away. Absolutely. The homicide counts are higher in the summer than the other seasons. So right away, that is an unusual blip, but we have to now decide in statistics, is that blip due to just random chance? They grabbed the 1,361 homicides completely randomly. It could just be from random selection that there's a blip right here. All the categories are equal. Or that might be significantly high enough that there is really some kind of statistical effect really going on underlying here. And that's part of our job with statistical methods. Find the right procedure and decide, is that little bump right here random chance, or is there something statistically significant really going on in the population itself? So here, if this was your response to this problem, I would consider that full credit. I didn't say mention 3 different things, and it's definitely true on the plot right here. Any volunteers for anything additional you'd want to include as well? Okay, well, let's maybe add just one more sentence just for the fun of it. We might also say the other seasons have about the same number of homicides. And so it's interesting to ask the question if the increase in summer was due to random chance or a statistically significant effect. Well, any questions at all, folks, on getting through the graphics for this categorical data here? Okay, let's see, we go from 5:30 to 6:45. We have a couple extra minutes. What I want to do right now is really just kind of a preview. So nothing you have to take notes on, but if you're curious, how will we decide if there's statistical significance here or if it's random chance? This is what's going to look like when we are on the other side of the course, probably around past midterms. We'll go to RStudio. The procedure we're going to need is going to be the chi-squared procedure because we have just one categorical variable. We'll type out this operation, chi-square.test, give it counts. If I give chi-squared nothing else, then there is an initial hypothesis. We'll call this a null hypothesis later on in the course, that there is no difference between the categories. The assumption is the number of homicides is equal for every one of the seasons. Now we're asking, if that assumption is true, that the number of homicides is always equal, what is the chance of getting this data as extreme as this data, where they're not unequal, or even more extreme? This operation is going to find out. So let's run it, see what happens. Oh dear. Oh yeah, there's a problem right here. Let's fix that. It says for the chi-square test, the p-value is 0.2578. So again, this is all strictly preview. You could just completely ignore me if you'd like, but it's interesting to see what we're doing with this. This is a probability. So if you like, you can think of this as a 25.78% chance, if you like percentages. And it means if we assume that the population really has an equal number of homicides per each one of these seasons, there's about a 25.78% chance of getting data as extreme as this, or even more extreme. 25% chance sounds typical, so it really looks like our data is consistent with the assumption there's no difference among any of the seasons. That's a pretty high probability. But what if we did this? I mean, this is outrageous, right? Put in, let's not go too crazy, 500. That's a 500. This bar goes way up here. That's got to be statistically significant, right? Let's run it and find out. So now the bar is way up here, and it's using scientific notation at this point. This is essentially effectively 0% chance, and a little bit more, pretty small, of getting data this extreme if there was no difference among the seasons. This is telling us our data really must be statistically significant at that point. Alex says, is there a video I can watch to download RStudio? I could only download the other version R. That isn't the correct one. I could look into that, Alex. Yeah, absolutely. Let me put here video for, and it's for RStudio specifically you're mentioning. Gotcha. RStudio. I'll look into that, Alex, and see what I can come up with. And possibly what might be pretty helpful for us is, I can't find a video, we might connect, say, over Zoom office hours, something like that, to see what the issue might be. So I'll take a look at that and get back to you. And Olivia asks, can you change the degrees of freedom in RStudio? You're referring to these degrees of freedom down here, Olivia? Well, you could potentially change the degrees of freedom, but the reason this says 3 degrees of freedom specifically is because it had to do with the number of categories up here. Oh, I didn't mean to move that. The degrees of freedom is the number of categories in your, oh, geez, I have a lot of tables here. Okay, I think I'm ready to start that thought, sorry. The degrees of freedom in the problem was the number of categories for that categorical variable minus 1. So we can't really change it without changing the data fundamentally, unfortunately. Other questions so far, folks, about this problem or what we did here as just a preview? Okay, well, for the purpose of the homework assignment, pretty much this is all we're really doing. The whole purpose of this is just to get some practice with RStudio. Producing graphics is a great way to start out. Here's the syntax if you want to readapt it for your problem. And pretty much all you would be doing is taking all this information right here, go to your problem, and, well, the counts will be more categories. So you change this and put in the numbers. The cause of death has several more categories, and you can abbreviate these if you'd like. You would just put them inside here, or in season rather. And then this bar plot would run exactly the same way. You wouldn't even have to make any changes down here. So that's how the first homework assignment is going to work for the categorical data. What we want to turn over to next is, what if the data is quantitative, numerical looking data instead? So that's going to be our next example. And in that next example, what we'll be doing is examining a histogram. There's a lot of information here, but the tough thing about this is all this is kind of meaningless until we see a histogram. So let's put a pin on that for the moment and take a look at example 4. Example 4 is going back to that data set that involves the children and whether they smoked or not, and their lung strength, FEV. So it says here, the forced expiratory volume, FEV, indicates how strong your lungs are, how well they're functioning, and it's the amount of air that you can expel in the first second after full inspiration, a full breath of air. The problem says, construct a histogram of the FEV variable. Essentially, we're just trying to say, in the FEV variable, where are all the data values located? How do they aggregate together? not too different from the bar plot, except there really are some pretty big differences, histogram to a bar plot. For example, in the bar plot, the ordering of these categories actually didn't matter. You could have put summer first and then winter, spring, fall. You could change the order of the seasons. You could do whatever you like. But what that means is you can change the shape of what you see here. But when it comes to numerical data, quantitative data, you cannot change the shape of that data. The reason is all of our data that comes in as quantitative data like this inherits the ordering of the real number line. So there really is a definite shape to this thing. We'll see it in the histogram. So that's our next thing to do. Produce a histogram of all of this data right here. This is just a snippet of the data set. So back at the Moodle website, the thing we're really grabbing is in chapter 1, we need to download this file right here, fev.txt. Then put in a place where you'll know how to grab it for your computer, downloads, or maybe the folder for the class, something like that. I have mine set in the thumb drive over here. Now, this is where RStudio is extremely helpful. Getting data in can be kind of a bear, but in RStudio, it's really just one little button, that import dataset button right here. First, you probably want to clear out the environment in case something conflicts in some weird way, maybe a variable choice and so on. There's a slick way to do that, but there's a broom right here. If you like clicking on stuff, you can just click on the broom. And with hidden objects, I honestly have no idea what that does. It doesn't seem to have affected the class in 10 years, so I'll just keep that checked. Here, you can make a new script. Just keep on clicking on these things. Or usually what I do, to be honest, is I save this and I just highlight it all, delete it, and start afresh right here. You can leave this here if you'd like. It doesn't cause any problems, but if you want to click on the broom icon here as well. Now we're about to import the data. And on the Moodle website, I don't have a video for this, but I do have a step-by-step guide. Where did I put that? Thought I did. I'm gonna have to include that on the Moodle website. I thought I had a step-by-step guide for including the data or importing data sets, but we'll do this a lot. So let's give this a try right here. I'll get that guide posted. Again, the first thing you want to click is import data set. This button right here. It looks like an Excel file next to a save icon. And we're just using the first option here from text base. If there's ever a call to change that option, I'll always let you know. And probably before letting you know is I'll just fix my data set so you don't have to use that. I'm always going to try to use option 1 here. So click on that. Now it's going to try to ask you to find the file for it. Mine is in a thumb drive. So I'll just point to that and click on open. So this will be the screen you're at. It looks terrible, but the way I try to format all my files, my Notepad files for these data frames is everything should be okay to just click on import. If there's ever a reason to change any of this stuff, again, I'll try to fix my data file first so that it becomes a non-issue. So right on the screen, everything is correct. Just click on import. The way you can tell is, notice the thing in bold, all of these categories, the actual variable names, should be the things that are bolded, not any of that data down below it. So visually, it looks correct if this is what you're seeing, and I usually ignore this information up here. So click import. We did it, folks. That's the data import. Now, what it actually had to do is this on the console. You had to go read dot eliminators and then very, very exactingly type out all that information that directs RStudio to your file. This is kind of tedious, so I recommend always doing it this way up here. Now, it gives us a couple different pieces of things. This new tab appeared. This is our data frame. We can scroll through it if we'd like, but it's just the original thing we threw up there. But you can also go here. Notice there's our play button. Click on that. It expands out to all of your variables. And usually this is what I'm looking at, this information right here. So I'm going to close this, get rid of it. And we've done it, folks. here is our information all right here. Any questions at all, folks, on the data import? Okay, so this thing is what RStudio likes to call a data frame. If you leave your mouse on it, it says FEV data.frame, and even tells you it's 19536 bytes if that's important. Going back to the problem itself, it asked us to do the following. Construct a histogram of the FEV variable. So we need to construct a histogram of this variable right here. We just move these windows over. So to make that happen, first thing we'll do is put in, if it wants a histogram, just start typing slowly, HIST, and it looks like that's it, histogram. So that's the function you're going to be using if you want graphics for quantitative data like we have here. Histogram's the right function, but we have to give it that variable. Well, there's a couple ways to do this. One thing you might do is type in the name of the data frame itself, FEV, and notice it says $FEV. The $sign here is a way to select the part of the data frame that you're actually going to work with. So hit Shift 4 for the $sign. And notice it gives you this little nice slider right here. Go down to FEV. And even though that's simple to type in, sometimes this is really important to just select it right here so that there's no weird white space issues or strange symbol issues that we might incorrectly type in. That's to just hit enter right there and get the exact values that we want. So if it wants a histogram of the FEV variable, import your data like this, put in FEV $sign to select the lowercase FEV, and that's what we're going to be plotting. Let's run that, see what we get. Control A and Control Enter. Finally, here's our histogram. Like before, we want to make some changes. The vertical label is just fine for frequency. The main title, usually I don't include that personally. You can fix it or delete it, your option. But down below, that wouldn't be acceptable. We need something nicer than FEV $FEV to indicate what's really going on here. So next thing we want to do is fix the X label. To do that, go X lab for X label, put in an equality, and we're just going to put in what we want. Well, it's FEV, it's measured in liters, that's indicated here, so let's type in FEV in liters. So that will fix our axis down below. And if you're not too keen on that title, here's a small trick that you can use, completely optional. Let me go to a next line. Main is talking about the main title. And if you go like this, you've killed the main title. You've given it nothing. So 2 quotes will wipe it out. Again, it's up to you. I'm not too worried if you include it or not. If you decide to keep the main title, we should probably fix that as well. So there's our new display. Before we get too far with this thing, let's take a really close look at that. For several folks in this class, or for many folks in this class, this is not a class that assumes knowledge of ordinary or intro statistics. This might be your first histogram that you've taken a close look at. Let's play with it a minute just to mention all the interesting features. This is the distribution of the FEV variable. So it's telling us what the actual outcomes were and where they occurred. So for example, if we focus on this category, in this rectangle right here, well, it ranges from, let's say it's about 3.5 up to 4. So if you have from 3.5 to 4 here, well, that's the FEV values. From 3.5 liters to 4 liters in lung strength. And this is telling us how many people, how many individuals in the data frame actually have those values from 3.5 to 4. You can go to the left here. At this height, pretend that's a perfectly straight line. Looks like it came down somewhere around maybe 48, if I was guessing, or maybe it was dead on 50, and I just have a shaky hand today. So it's telling us here, from 3.5 to 4, so pretty strong lungs, there was about 48-ish children altogether. So that's what the histogram is telling us. How many individuals fall on these specific ranges on the histogram? Does that make sense to folks on just visualizing what that information is? Okay, again, this is very different from a bar plot all of a sudden. In the bar plot up here, notice that there's gaps between all these bars. That's specific to remind us it's a true bar plot, and the ordering of these categories did not matter as much as it seems. Over here, there is no gap. We're dealing with quantitative data, and the shape of this is fixed. We cannot do anything about the problem to change the shape unless you're actually changing the data, which we definitely don't want to do. That means we have it, folks. That's our histogram. Any questions at all on producing these graphics? Okay, so over here, let me click on, let's see if this works again. Copy plot is what you would typically like to do. Then down here, Control V to paste it in. It looks like I have some weird anomaly with my graphics. I'm gonna have to update RStudio for sure. That's what it uploaded for us. Not quite right. Let's fix that. So if you're having the same issue as I'm having, and maybe I should ask in class, for folks following along, if you have your laptop, which is not required, but if you are you getting that same weird issue on pasting those in? Gotcha, that might be, it's working for you? Gotcha, looks like it could be just the update that's missing. So another way you could get through this is, if you're having the weird issue like I'm having on your machine, if it's a Windows machine, hit the Windows, the Shift, and the S key. It was like some play a guitar, something weird finger arrangement. Then just move your cursor around. I would go from about here to here. And that could be your way of getting that into the system. That wheel plot, hit Control V, and there's our histogram there. Is that working out for folks so far in class or in Zoom? Okay, well, when it says construct a histogram, this is all we're going for. And there's a lot of modes you might be doing your homework assignments. If you're using ordinary pencil and pen, that's all right. You could just email these separately as part of your assignment. I'd be completely fine with that. Or print them out and attach them to the last pages like we mentioned. Well, we've got our histogram. We have a feeling for what's going on in that histogram, but let's go back to the portion above and take a look at all this information again once more when we examine this histogram. And maybe before I forget, let me go to here, and this is how we got that histogram to plot. Just a one line. There we go. So some of these things are really pretty fast to get into RStudio. And this is our big function for whenever you're dealing with quantitative data like we had. Next, we want to comment on the shape, center, and spread of these data. I would say this one is the major one. Center and spread is going to be a little bit weird in this lecture and on homework assignment 1, because we're saving chapter 2 for actually computation of the statistics. We would compute the sample mean for the center and the sample standard deviation for the spread for these data. It's not too skewed. But in chapter 1, we haven't quite gotten to those concepts, so we're doing everything completely qualitatively. Same as in the homework assignment. Kind of uncomfortable, but if you want to calculate the statistics, you will never lose credit for knowing stuff. You can calculate the mean standard deviation, up to you. So let's tear it up to the top here. First thing that I want to point out is this is definitely good information to be aware of. If your variable is quantitative, you want to use the histogram operation. If it's categorical, go for the bar plot. Let me just put that down here. Let's see if I can get these all in one line. Next thing we'll take a look at is, we want to take a look at any kind of pattern, any kind of weird shape that we might see any kind of observation that might be far away from the main pack of the data. But another thing we're going to take a look at is whether the histogram is going to be symmetric or at least roughly symmetric versus potentially skewed in one direction or the other. Now, looking at this histogram, for symmetry, what you would want to do is try to find about where the center is on this thing, where the main peak is, for an example. If I were to plot a center on this, I'd probably move it slightly to the right around here. Now, if you fold the paper over, pretend this is printed, if the rectangles of the histogram roughly overlap, when you fold across that dotted line, that would go to here, that would go to here, that one would go to about to here, and so on, then you're looking at data that might be just at least roughly symmetric. Oh, let me go to Control Y there so far. Does that make sense to folks on symmetry for these data? Okay, so as far as the shape goes, I would say that we're dealing with something that is definitely at least roughly symmetric in this situation. We usually don't see perfect symmetry when we're dealing with actual real world data. We might have to use random data from something that was already symmetric to see it. So on this, we can say for shape, the distribution of FEB is roughly symmetric. So that takes care of the shape on this one. But we want to know also, when would we say it's skewed and what direction would it be? So for that, let's maybe come back to center and spread and just look at a couple more histograms for when they would definitely be skewed and we wouldn't say roughly symmetric. Any questions first so far? Okay, let's see if we can put it down here. So if we're dealing with something that's, say, skewed to the right, the shape of the histogram would look more like this. Oh, that might be a bad idea. Let me just use ordinary colors here. Skewed right data has this kind of feature. There's really no symmetry at all that you're looking for data that's perfectly skewed to the, not perfectly skewed, but definitely and substantially right skewed. This would be right skewed for data. And what causes it to be right skewed is this right here. The data is trailing off to the right, and so that's the direction of the skew for these particular data. The right tail of the histogram extends much further than the left side, in other words. So that gives us the skew in that picture. Next, if you want data that's less skewed, it would look about like this. And it could start off roughly symmetric, say like the data that we just looked at. If these were our data, I would say this is highly symmetric at this stage. If this was a project that you were working on, some kind of research study, people would almost celebrate when their data comes in and looks like this because this is very, very manageable data. But if your data starts to do this, it has an apparent skew. I'd still call that roughly symmetric at this stage. Here, we're starting to get some problems. There's a left skew. If the sample size is large enough, we might be able to overcome this and use still some very powerful methods. But now the central limit theorem we'll see later and the sample size are going to decide that for us. But there's no limit to how skewed things can come out. There might be more data here. There could be some gaps and more data piling up around this range. We might call these ones outliers at this stage, but these data would be left skewed. The skewed for the left on this one is because of the tail going off to the left extend much further to the right than the tail going off this direction. So we have left skewed data in that case. These data are very hard to handle. We might have to change to a different procedure if the sample sizes are low. That's unfortunate because those procedures are called non-parametric ones, and we lose a lot of power in the conclusions we can give for those kinds of procedures. So we hope we have something at least roughly symmetric or high data or high sample sizes. And in this case, this one's not too bad. The sample size is tremendously high, and it doesn't have too much skew. We called it roughly symmetric, but if you were going to say it did have a skew, what direction would it be? Towards the right or towards the left? I agree with folks in class. Folks are saying towards the right. And I agree, right here is a slight. Let's emphasize that. This is not enough to say it loses symmetry, but it does have a slight right skew. So that's our shape of these data. We're really happy when we see symmetric data and a little bit worried when it comes out worse, say skewed in one direction or the other. Next thing we'll need to take a look at is what is the center of the data? When you're looking for the center, you're just trying to find the position where, well, it's the most typical value at all. If you were to go along the lines here, any volunteers for where the center might be? How about a volunteer in Zoom, just to bring in the Zoom side of the class? Any volunteers on Zoom on where the center ought to be here?
Probably about halfway between 2 and 3.
I would agree with you on that. The center should be somewhere around here. And the idea with that is, if you chose this value here, as you did, then there's a bar that goes up like this, and roughly 50% of the area should be to the left of that, and 50% of the area of those rectangles should be to the right. If that's the feature, then you found the center of these data. What you really found, if you're thinking about areas, is that's the median value. That's not necessarily the sample mean that we might be looking for. But visually, it's pretty easy to spot a median or central value. The data is symmetric, the median and the sample mean are very close to each other. So we'll say the center is at about 2.5 liters for these children. So this is the way I think our author intended this question to be answered when we're just in example 1. It's a bit uncomfortable, but if you want to work a little bit ahead, you could do this instead. It is optional. We'll look at this when we're in chapter 2. But you could just simply write in, we want the average. In our class, we call the average the mean. So we'll just say mean, open this up, give it FEV, $, the variable we're working with, lowercase FEV. If you run that, it gives us the mean at 2.63. Visually, it was indicated about 2.5 liters, and so that means we're on the money. That's really very great for just doing this visually. Again, this is the answer that's expected, but if you decide to work a little bit ahead, I'm okay with the actual statistic itself. Your option. Any questions, folks, with the center? Okay, spread is also a little bit weird, but this is all qualitative, so we'll do it this way. The spread is just going to be from the minimum to the maximum. It's tricky because I'm not trying to go to RStudio and find the min or max. It's not hard to do, but for doing it qualitatively, just looking at the histogram, you might answer this question by saying, let me try again one more time. Here we go. For the children in this study, the spread of FEV values ranges from, I'll say this word here again because it's visual, purely qualitative, approximately, go to the lower end, and I'm not too sure what's out here. You might say 1 liter or 0.5 liters. I'll go with a 0.5. Either a very small child or maybe that one was under the weather or something like that. Up to 6 liters. From 0.5 liters to 6 liters. And that would be how we might decide the spread of the data for this problem here. If you're doing it in, say, RStudio, you could just do this. SD for standard deviation, FEV, $ select lower FEV, and that's the standard deviation right down there for the data set. So completely up to your option, either calculate statistics. I expect more people will be comfortable doing it this way. We'll only start the statistics on chapter 2 coming up. Well, we did it, folks. That's the end of the notes. And this is pretty much what you're also going to be getting to on the homework. If you have any questions while you're working them, don't hesitate to reach out. I'll be very happy to help out. Otherwise, I think we're just about there, folks. We do have a chat. Olivia asks, so spread is always describing the x-axis, not the y-axis. Yeah, if we're looking at a histogram, it'd be the horizontal spread x-axis. That's right. Specifically for histograms. Well, any other questions, folks, before we call it a day? Okay, well, have a great weekend, a great holiday, folks. I'll see you all next Wednesday, and we'll be in chapter 2.
Is chapter 2 part of the first assignment?
It is not. Yeah, so we're all set for assignment 1.
Thank you.
Yep, you betcha.
So I had a question about the textbook.
Yeah,
Um,